Alright, what we've got here is a 4-stroke motor, and I'd like you to pay attention to these valves right here, because this is 4 strokes, and I'll show you the strokes have to do with up, then down, up, then down. Those are the 4 strokes. Alright, so let's start at the beginning right here. So when it's down the last time, the exhaust port is open. Here's the head that's removed from there. The exhaust port is open, and so the engine is, when the engine comes up, it pushes the exhaust gases out, and then as soon as it gets up to the top, the exhaust valve closes and the intake valve opens, because now it's going to pull fresh air in. So that was 1 stroke, is exhaust. Then comes intake. And then as soon as we get down to the bottom, that valve is going to close. And now as it comes up, it's going to compress the gases. And it compresses them up to right here. They're all compressed. And as soon as it gets to this spot right here, then what happens is the spark plug, which comes in this hole right here, the spark plug is going to ignite, and as it does, it forces the valve back down, or the piston back down. So you've got intake, compression, ignition, and then exhaust here. Exhaust here at the end. Okay, so let's start again. Intake. No, that's exhaust, sorry. Intake, compression, ignition, and then exhaust opens. And it starts all over again. Intake, compression, ignition, and then exhaust opens. But the main thing that we're doing today is we're measuring the size of this engine. And so what I can show you is that if we measure this engine to the nearest, using this meter stick, we get about 2 3/4 inches going across there. Okay, and then the depth is around 2 inches. So those are our 2 measurements for our cylinder. But that's a very crude approximation of what the actual size of that part of the engine is. Actually, we can use this digital caliper to measure the size, and we see that it is actually, from side to side here, 2.7975 inches. Well, 2.797 inches wide. And this is kind of neat. If you put the caliper here on the edge, you can see this thing going down. And as it does, that will be used to measure how much depth there is here to the bottom. And we get 1.925 inches. 1.925. There's a more precise way to measure the diameter here, and that's using this tool. And what you do is you get it in there, and then I'll show you, you expand it out. So you see how these springs, it's spring loaded, but you get it in there so it's tilted down, and then you tighten up the knob so that when you get it through here, when you get it through here, as you tilt it back up, you compress that spring and it gives the exact distance. So this is the exact diameter. The small motor guys say this is the way to actually measure the depth, and then you measure that using the dial caliper here. And the reason why people don't use dial calipers more, frankly, is that they are really difficult to read, but extremely precise. Okay, so I'm going to get it the right depth here. Okay, so the depth is 2, and then you got to start reading it from the end here. So it's 2, and then you read this dial here. I'm sorry. Yeah, 2.8. It's just past the 8, and it matches up exactly with the 5, only a little bit past the 5. So it'd be 2.85, and then maybe 1 or 2. You can figure out exactly which one it is by seeing which one of these measures up, and it looks like it exactly matches up with the 1. So it'd be 2.851 inches, which I think. Alright, so what we're doing here is measuring the volume of this engine cylinder head. And the way you do it is by the displacement of water. So to keep the water from leaking out, I'm going to put a Vaseline seal between the head and the gasket, and then between the head and the gasket and my plexiglass here. The engine goes right onto, or the head goes right onto the block, and so there is no more gap than what you see in this part here. I think I'll just do one side. I'm somewhat concerned that I'm going to get a little volume into the engine, but I'm more concerned that I'm going to leak water all over the kitchen cupboard, which it won't be as bad as the time that I burned salt on the stove to see what temperature it melts at, which, by the way, I never did find out because the pan got ruined first. But anyway, that's another story. All right. So now I'm going to scooch this down onto the plexiglass. Maybe get some more light. And then I'm going to use this volumetric pipette and a piece of paper. The paper records how many milliliters I put in, and we're going to fill that engine cavity with water. So for this first time, I have starting at 2 milliliters, so I'm going to go from 2 milliliters down to 22, and that means I will have put 20 milliliters in. So then I'm going to write that down, otherwise I will forget. So I've got 20 in there so far. Okay, this time I'm going to go from 1.4 milliliters down to 21.4. And I believe I filled it up. So it went down to 15.6. So 1.4 away from 15.6 is 14.2 milliliters. So 14.2 onto 20 makes 34.2 milliliters is how much that head holds.